Algebra 2, Lesson 80, Direct and Inverse Variation as Ratios. So, I've already been teaching you guys this ratio variation. It's something that we've been using pretty often, and it's this one over here on the right, or sorry, the left in green. This is direct variation. Don't worry about the blue yet. Yeah, I'm just gonna, there. Don't worry about it. So this is direct variation. This is something that we've been doing for a while now in our ratio and proportion problems, which is that, if A is to A as B is to B, that's how we would read direct variation. And there's two ways we can solve this. We can either use the proportion method, which is A is to A as B is to B. We use that one a lot. Or we use the scale factor method, which is A equals scale factor or constant times B. Okay. We'll go ahead and solve a direct variation example really quick to show you what that's like. So let's say they tell me that, we'll look at this example here. 80.2. They tell us cost varies directly as the number purchased. If 12 can be purchased for $78, how much would 42 cost? Okay, so 12 can be purchased for $78. How much would 42 cost? This is a direct variation, and I'll go ahead and use both of these methods. So if 12 is to 48 and 12 costs $78, how much does 48 cost? That's one way to do it. The other way, if you're going to use, well, we'll go ahead and solve this. Since we're familiar with this, we cross multiply. We get 12x is equal to 48 times 78. Divide each side by 12. That's going to cancel, become 4. 4 times 78 is, yeah, let's just go to calculator. 4 times, oops, clear, 4 times 78 gives me 312. So X is going to be $312. Now that is the direct variation using proportions. Now let's say we wanted to use the constant or the scale factor. So what we'd do here is we'd follow this cost of 12 being $78. So the way we'd represent that using this equation or this constant equation, scale factor equation, is we would say 12 is equal to K times, sorry, not 48, $78. $78. So all I have to do is solve for K. I divide each side by 78. Then I find out that K is equal to 12 over 78. Now, if I want to find out how much 48 cost, I'm going to apply the same equation, but I'll plug in this for K instead because I don't know how much it's going to cost. So it would be 48 equals 12 over 78 times X, or the new cost. From here I'd multiply by the reciprocal, 78 over 12, that's going to cancel these. And then here I multiply by 78 over 12. I get the same thing, that's going to cancel, that's going to be 4. 78 times 4 we just learned was 312, and that is going to equal X. So that's direct variation using proportions and scale factor method. Now let's compare that to indirect variation over here in blue. Now indirect variation is very, very subtle. See here in direct we had A1 was to B1 as A2 is to B2. In indirect we have A1 is to B2 as A2 is to B1. Easiest way to remember this is that the partner to whatever number you're dealing with goes to the inverse location of the fraction, or A1 is to B1 goes underneath, A2 is to B2 goes on top. So they're on opposite ends now. Now let's go ahead and solve a problem using inverse variation. They tell me blues varied inversely as yellows squared. If 100 blues go with 2 yellows, how many blues go with 10 yellows? Now the other thing that they throw out here is this term yellows squared. So I can't just put yellows, I have to put yellows squared. So sometimes with indirect or inverse variation, I like to write out the equation first so I don't get confused. So if blue 1 is to blue 2, and blues vary inversely to yellows, that means that yellow 1 is going to be down here, but it doesn't just say inversely, it says yellows squared. So I'm not just going to put y1 down there, I'm going to put y1 squared. And then on the top, I'm going to have yellows 2, but that will also be squared. So this is very important when I go to solve this equation, because when I start filling in the blanks, which is they tell me if there's 100 blues with 2 yellows, the way I'm going to fill this in is the 100 blues will go on top, and the 2 yellows will go on bottom, but those 2 yellows get squared. So that's how we do inverse variation, and that's inverse squared. Now, they want to know how many blues will go with 10 yellows. So blues 2 is the missing, and then 10 yellows goes on top, but that also gets squared. So when I cross multiply, what I get is 10 squared is 100, so I get 100 times blues is equal to, let's see here, 2 squared is 4, 400. 400, so when I divide by 100 on each side, I get that the number of blues is 4. And that is correct. So that's how we do it with proportions. That's inverse variation with proportions. Now let's say I wanted to use the constant method. The way I would set this up is that first factoid of information, 100 blues going with 2 yellows squared. I'll go ahead and make 100 blues A, so 100. And then remember it's an inverse variation, so yellow squared is going to go on the bottom. So that's 2 squared. And then my constant k will be on top. So now I just have to solve for k. So 2 squared is 4. Go ahead and rewrite that. If I multiply each side by 4, that will cancel. So then I get k is equal to 400. So that's my constant. Now I'm going to fill the equation in again, but this time I'm going to know what the yellows are. So A is going to equal 400 over 10 squared, or sorry, blues. The number of blues is going to equal 400 over the 10 yellows squared. 10 squared again is 100, so we get 400 over 100. The zeros cancel. And then I get that blue is equal to 4. All right, so that is that's inverse and direct variation as a ratio and as a scale factor. So these are the things you need to memorize. Both of these are useful. You only have to pick one. Proportions will probably be easier because we've been doing a lot of that this school year. And I think if you've done math with me for more than 1 year, I really harp on proportions like ever since pre-algebra. So that's all there is for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.